Today's question comes from David, and he asked it back in 2018. So hopefully, Sophia is not sitting around still waiting for an answer on what to do with her farmland, but now we can give her a conclusive solution to what she should have done. If you want, you can go ahead and pause here and read the problem as is, or you can allow me to kind of simplify it by organizing it just a little bit better. So Sophia here has $15 to spend, and she's got 24 square yards of farm to work with. It cost her $1 to grow tomatoes, and it cost her $3 to grow beans. Tomatoes also utilize 2 square yards, where beans utilize 4 square yards. She can profit $2 off of every bushel of tomatoes, and she can profit $5 off of every bushel of beans that she sells. Now she has to grow one of each, but the question becomes, how many of each bushel should she grow to maximize her profit? Now with all that explanation out of the way, we can finally hit our whiteboard and start tackling our problem. So first we're going to need to identify what our objective function is. An objective function, simply put, is the ultimate goal that we're after. And in this case, the goal that we're after is to help Sophia maximize the amount of money that she's going to be making. So what we need here, we know that selling a tomato generates us $2. And selling beans generates us $5 in profit. And then if you give me a second, I'll switch over to the little images here. So 2 times our tomatoes and 5 times our beans is what we're going to need in order to maximize our profit. And then I've gone ahead and written just the more formal approach of where x would be our variable, and we do a little subscript of t to account for tomatoes, along with a little subscript of b to account for when it's beans. Now that we have our objective function squared away, we need to start going over what our constraints are that restrict us in this problem. Now let's begin with our constraints. And what our constraints were, well, we know that we need to at least plant 1 tomato and 1 bean. So we would simply just write this as x subscript t must be greater than or equal to 1. Similarly, x subscript b must be greater than or equal to 1 as well. We also have that additional constraint that x subscript t cannot exceed 8. So it's got to be less than or equal to 8 as well. Next, we need to account for our square yards that we have available to use. So for our yards constraint, we know that, once again, tomatoes, they required 2 square yards in order to be planted. And beans required 4 square yards if we were going to plant them. And when we recall how many square yards she had available, we know our answer needs to be less than 24. Equal to or less than. Next comes lastly comes the amount of money that she had to invest to begin with. Tomatoes cost $1, and beans cost us $3 to purchase. And then the total amount that she had to begin with was $15. So this needs to be equal or less than 15. That comes out to the cost. All right, now I'm going to move this over just a bit so I get my white space back. All right, so now at this point, we're kind of at a spot where we either take this to a computer or we start checking solutions by hand. If we were going the hand approach, my initial suggestion would be, let's try to maximize beans because they give us the most profit. So we'll see how many beans that we could possibly put into our equation and we have to have at least one tomato. So with that being the case, the first point I would check would be 3, 4, where we're accounting for 3 tomatoes and 4 beans. With our constraints, we'll get 2 times 3 plus 4 times 4 less than 24. And that checks because this becomes 6, this becomes 16, and then that becomes 22, which is less than 24. Similarly, let's get rid of that. So that one's good. This next one will have 3 plus 3 times 4, which is equal to 15, which is less than and equal to 15. So therefore, this one works, and we can use it. Whether it's the most optimal solution or not is still yet to be determined, but we can plug it into our objective function up top, and we'd get 2 times 3 plus 5 times 4, which comes out to, I'll just go straight for the gusto there and go 26. So the question is there another solution we could have gone with that would generate more in profit? Up on the screen now, I'll post all the possible solutions if we're going the hand-checking route. And the only one that we've checked so far is the solution 3, 4, so the rest still need to be checked to see if maybe those get us an objective function that gets us more than $26. Also, if you made it this far in the video, please leave a like, leave a comment on your take, and let me know if I missed one of the possible solutions for sure. Here we are in Python now, and I'm importing the pulp library, that way we can get our optimization functions. I've got the same constraints, just listed a little differently. So instead of tomatoes, I went a little lazy, and I'm just going to call them Tom. Along with, it's got its lower bound of, it has to at least be 1, and it's got an upper bound of 8, and it needs to be an integer. So no planting half tomatoes, half beans on any given little square yard. We have our bean variable, which also has to be a lower bound of 1. We have our objective function, where it's 2 times our tomatoes and 5 times our beans. Along with our constraints are there of, we only have 27 or 24 square yards available. So we've got our 2 for the 2 times our tomatoes and our 4 times our beans, and has to be less than 24. Our $15 to invest is still there. And then so all that's left is just to hit run and let it solve, and it's going to just tell us what our optimal tomato amount is and our optimal bean amount is. So we'll hit run on this, and there you go. It's checked through all the solutions, and it's telling us that the optimal tomatoes is 6 and the optimal beans is 3. And that would get us, all right, I was never going to beat this, 0 seconds to run through all these calculations. We get an objective value of 27. So in this scenario, she makes $27. So that is our answer on how many tomatoes and how many beans we have to plant, given our constraints.